Hi everyone, it's Coach Fred here, and we're going to be looking more deeply at finding domains today. In our last video, we talked about determining if something was a function. We talked about what a domain was and a range was, and then we talked about looking at ordered pairs or relations or mappings to find domains. But today we're going to be talking about how to find a domain algebraically, okay? So let's have a reminder that if we're given a function, the domain of the function is the set of, and I changed the word a little bit, I made it permissible inputs. So our x values that are allowed to go into the function, and the range will be the set of those resulting outputs, or the y's. Okay, so it can be a little bit more challenging to find domains algebraically, meaning we have to look at a function equation and determine what the domain and actually the range would be. Typically, ranges are often going to be found both algebraically and graphically, and the graphic way is going to really help. But for now, we're going to look at domain. Okay. All right, so algebraically just means we're going to look at an equation, a function equation, and determine the domain. Okay, so when finding the domain of a function, just ask yourself, what values are not allowed? What values are not allowed? Meaning they would make the equation either undefined or something that we can't graph. So if you find the values that are not allowed, your domain is everything else. And I'm going to show you what I mean, okay? All right. So let's look at some basic rules to consider. These are some of the basic rules. Polynomials, the functions that we've looked at thus far, or you have in the past, linear functions, quadratic functions, and in some cases even exponential functions. If I were to create a table of values for any of these, is there any value of x I'm not allowed to input? Can I plug in -1,000,000? Can I plug in -1,000? Can I plug in 0? Can I plug in 1? So the rule is, if it's one of these three functions, the domain will be all real numbers because I have no value of x that's not allowed. They're all allowed. So if all the values of x are allowed, then the domain would be all real numbers. We could write it like that. Now I'm going to introduce something to you called interval notation. Another way to write all real numbers would be using parentheses and say -infinity, infinity. We're going to talk more about interval notation later on, but I'm just going to let you know right now that's a way to write all real numbers, okay? All right, so that's a basic rule. If it's one of these three functions, then the domain will be all real numbers. All right, here are the ones that we need to pay particular note to, okay? Square root functions cannot have a negative underneath the radical. Now, you haven't spent a lot of time on these, but I know you know that you can't have, if you got like -5 under here, you can't do that. We can't graph that. That's a complex number, okay? And so we can't have a negative underneath the radical. That would be not allowed, okay? So to find the domain, set the expression under the radical greater than or equal to 0 and solve for the variable. That will be your domain. All right, so here's what I mean. If I set this greater than or equal to 0, when I solve for x here, this is going to be the values that's going to make it a positive number, which is what I want. So I'm going to add 3 to both sides, treating it just like an equation. So I know that x has to be greater than or equal to 3 in order for this function to work. So my domain is x's, I want all x's greater than or equal to 3. All right, so again, that interval notation that I told you I'm going to do a full lesson on, I want you to see what that would look like. That would look like a bracket with the number 3 and then a comma to infinity with a parentheses. I want you to think about that because I'm going to be asking some questions when we start working on interval notation about how that relates to that. Okay, let's look at the next one. Again, we set what's under the radical greater than or equal to 0 because we need that value to be positive. So by setting it greater than or equal to 0 ensures it will be positive. All right, so I'm going to subtract 1. and then I'm going to divide by 2. So x's will need to be greater than or equal to -1/2 in order for the value under the denominator to be a positive number. Okay, so how would we write that? Using this new thing called interval notation. Okay, we would write hard bracket, I call that a hard bracket, -1/2, comma, infinity, parentheses. All right. Here's our last one. 3 minus 2x. Okay, I'd like you to go ahead and solve the domain and answer the question on Edpuzzle. All right, so if you did your Edpuzzle, you set this greater than or equal to 0. You subtracted 3. Now, here's where it got tricky. You are dividing an inequality by a negative, and anytime you multiply or divide to the x in an inequality, you have to flip the sign of the inequality. So if x's are less than or equal to 3/2, then you will have a positive number under the denominator. Now we're going to talk about this more, but this is a review from your Algebra 1. Right, when you divide an inequality or multiply by a negative number, you have to flip the sign. All right, so how would we write that? Now, this is interesting because I want all x's less than or equal to 3/2. So the way we'd write that using interval notation for the domain. Again, this is domain. This is the domain. We could write the domain this way too. We would write that parentheses, negative infinity, comma 3/2. Hard bracket. Wow. Okay. All right, let's move on. Another one that we have to really be careful are rational functions. Now, we have spent time on rational functions this year, okay? Remember, rational functions, you cannot have zeros in the denominator. So right now, you guys, I've made you find what I called your restricted value. Your restricted value is the values that x can't be. So the domain is everything else. All right, so let's look at an example. Right now, I know this restricted value would be 4. X cannot be 4, otherwise the denominator would be 0. So first I'm going to write that. That is not the domain. That number is not in the domain. So it is everything else. I'm going to show you how we'd write that in interval notation. We would write that as negative infinity, comma 4. There'd be parentheses here. Now this time there'd be parentheses around 4. And we'd use this symbol called a union. And then we'd have a parentheses again, 4 and infinity. Now, you might be asking yourself, what's the difference between the bracket and the parentheses? So I'd like you to answer that question as it appears on Edpuzzle now. All right, let's try the next one. My restricted values, I'm going to write those. My restricted values here would be -1 and 3, okay? X cannot be -1, X cannot be 3. Okay? Now remember, that's not the domain. The domain is everything else, okay? So let me show you what that's going to look like. Again, I'm going to do a formal lesson on interval notation, but the more you see this might help. And I really want you to think about what I'm doing and what this is covering for me. So using interval notation, it would be negative infinity, comma, -1, parentheses, union, -1, comma 3, union, 3, comma, infinity, okay? So it's really important that I'm using parentheses here. Why? Because parentheses means does not equal, okay? Does not equal. All right, last one. Let's look at this one. How am I going to find the restricted values here? Well, hopefully you see it's quadratic. In order to find those restricted values, I have to factor it, okay? So I'm going to do that. I'm going to factor the denominator. So I'm looking for the values that multiply to -16, that add to -6. Hopefully you're seeing that would be -8 and +2. Those multiply to a -16 but add to a -6. So my restricted values are x cannot be 8 and x cannot be -2 because that would give me a 0 in the denominator. I'm going to ask you to try and see if you can write this with interval notation. Okay, don't worry if you don't get it. It is a complicated way to write it, and I am going to go over it, okay? All right, guys, so that's one of the things that I wanted to spend some time doing today. I wanted to talk about how to find domains from using algebra, okay? All right, and I'm actually going to stop there today. Have a great day.